So we'll keep going. All right, so notes on systems of inequalities. So last week we started systems of equations. For the past 2 weeks, we've been doing systems of equations, and now we're going to do systems of inequalities. So with systems of inequalities, these are your 3 steps you follow to find a solution graphically. First, step one is to solve each inequality for y. So as you can see here, and the full example, each inequality, 2y minus y less than 1, and x plus y greater than 1, x plus y greater than or equal to 1. We solved them for y. Please remember that when you multiply or divide by a negative, so notice here I multiplied by a negative. When you multiply by a negative, it's going to change the sign. So I went from being greater than to being less than, okay? So when you multiply or divide by a negative, not only are you changing the sign, but you got to remember to flip that switch, okay? But solve for y, done. And then we call them boundary lines. So we graph the boundary lines, okay? So you graph the boundary lines. If it's a greater than or equal to, or a less than or equal to inequality, then it's going to be a solid line. If it is greater than or less than, then it's going to be a dotted line, dotted or dashed, whatever you want to call it, okay? And then you're going to shade on the appropriate side of each boundary. So you can't see it on the copy because for some reason all my shading did not. But when you shade where they overlap, that's your solution, and that's the piece that you want to make the darkest, okay? So where they overlap is your solution. When you're shading, how to know what to shade, if you are less than or equal to, you're going to shade below the boundary line. If you are greater than or equal to, you're going to shade above the boundary line. Okay? So shade below, shade above, and then where they overlap is our solution. So we have 3 examples to do together, and then you have 6 problems to do on your own. Are you ready? Yes, we're good. I don't want anyone to think I'm rushing. All right, so this one is already, so step 1, isolate y. Is y already by itself? Yes, so we're good to go. So step 2 is to graph. So if I have y, x, y is less than or equal to x, a couple of things I know. I'm going to have a solid line. So my line is going to be solid. I also know that my slope equals 1 and my y-intercept equals 0. Agree? Because it's the parent function. So I'm going to go here and I'm going to graph this accordingly. I kind of need all the dots so I can try to draw my very best straight lines. You guys can probably do this a lot easier than me. People at home, I strongly encourage you getting graph paper or having your parents print you out graph paper. Okay. And then I also know, because it says less than, I'm going to shade below. So I'm shading below. Okay, so there's my below shading. And you want to do it lightly because when you darken, that's where you're saying the solution is. So I did the first one. Now I'm going to do the second one. So the second one, it's a greater than or equal to. So I know it's solid. And I am shaded above from the 3x minus 1. I know that my slope equals 3 and my b equals -1. B is where I begin. So I go to -1. And from -1, I'm going to rise 3, run 1. 1, 2, 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 3. I ran out of room. Now I'm going to reverse it. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. And I'm going to connect my dots to the very best of my ability. That is the straightest blue line you've seen today. Okay, this time it says that I'm going to shade above. So I'm going to shade above. I'm going to choose a different color. I'm going to shade above. If you're hesitant on where to shade, choose a point to the left or to the right and test it. And I'll show you what I mean in a second. All right. Here we go. So the area where they overlap, that is my solution space. So this is where my green and my yellow become friends. So this is my solution space. This is my solution space. I'm gonna make it dark. This is my area of overlapping. All right, bam. How do we feel? It's like a coloring activity today, right? Kind of. I'll take that. All right, well, let's try another one. So this time I have to go through with step 1 because my y is not isolated. So I'm going to have to get my y's by themselves. So the first one, I have 2x plus y is greater than 3. So I subtract 2x. And now this is going to become y is greater than -2x plus 3. And then my second one, I have x minus y is less than 2. I'm going to subtract x. And I'm left with -y is less than -x plus 2. I'm going to multiply by -1. And what happens when I multiply? It switches all the signs and it flips the switch. So it becomes a positive x and a -2. So now I'm working with y is greater than x minus 2. And now I can graph them. So then we graph them. So I'm going to graph x minus 2 since I already have the blue going. So this tells me that my line is dotted. And I'm going to be shaded above. This tells me my slope equals 1 and my y-intercept where I begin is -2. I'm going to go to -2 and create my I actually like doing the dotted dash ones because I make my dots and then I just put little dashes in between. And I don't have to worry about trying to keep a straight line. Because bam, it's done. Okay, and it says I'm going to shade above. So I'm going to shade above. All right. And now I'm going to do the red. So on the red, I know that I am also dotted or dashed, whatever you want to call it. I'm also above. And my slope equals -2. And I'm going to begin at 3. So I go to 3, 1, 2, 3. I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Going to continue. Oh, I went over too many. And I'm going to go up 2, right, left 1, up 2, left 1, up 2, left 1. And again, beauty of it being dotted and dashed is that I just put some dashes. Okay, it's a decreasing line. So when it says shaded above, that's shading to the right. So I'm going to shade above it. And again, my solution space is where they overlap. So they overlap right here. So I'll make it dark for you and myself. If I was on paper, I would color it all the way in, but I'm on paper, so. This is as good as it's gonna get for y'all. After doing example 3, do you feel even more confident? Cool, cool, cool. And then we just have one example left. All right. Already isolated. So part 1 is done for us. And we just have to start graphing. So part 1's already done. Use what we have. I see that I'm going to have a dotted line. And it's going to be below. And then from here, my slope equals -1/3. And my b equals -1. So all of that I've identified, I'm going to use it. So I'm going to begin at -1. And I'm going to go down 1 and right 3. Down 1 and right 3. Down 1 and right 3. Reverse it, up 1 and left 3. Up 1 and left 3. Up 1 and left 3. And then draw my dashes. And we said that it's shaded below. There we go. Okay. And then the second one. We have y is greater than or equal to 3x plus 1. This lets us know that we're going to have a solid line. And it's going to be shaded above. Above is spelled with a B, not a D. And here my slope equals 3. And my y-intercept where I'm going to begin is at 1. So I'm at 1. And I'm going up 3. Over 1, up 3, over 1, up 3, over 1. And I'm going down 3. And this time it is a solid line. So I gotta do my best at making the best straight line you've ever seen. And now I'm going to shade above. And where they overlap is my solution. So I'm going to make mine darker so I can see it.
So what if, like, there's a question that says, like, there's no solution, would it just be opposite to each other?
Mm-hmm. The lines will be parallel. And one may end up being shaded above, and one may be shaded below. All right, how do we feel? Easy breezy? A day of coloring, yay! Okay, so I'm gonna pass out your classwork or at home. You're gonna do your best to sketch and color at home, but face-to-face, I have your paper for you. And that is it for today.